Hi dear students, let's see this question that came in JEE Advanced Paper 2 Physics in the year 2019. The question was from the topic of rotational motion based on multiple choice correct marking scheme. One of the easiest questions from the topic of rotation that has been asked of late. Most of the students who wrote JEE Advanced would have gotten this question right. So in this question, there is a rod that is kept on a kept on a rough horizontal surface, and it starts rotating about its bottom end. So basically, if you consider a ground, right, and this rod, this rod starts rotating because of slight disturbance maybe, and the friction is so high such that this bottom end is not sliding on the floor. Okay, so when the rod makes an angle of 60 degree, at the instance this rod makes an angle of 60 degree with the vertical, at that instance we have to talk about the angular acceleration, angular velocity, normal reaction, and radial acceleration of the center of the mass, right? So let's do this question. Mass of the rod is m and length of the rod is l. Now first thing will be to find the angular velocity of the rod at this instance. That can be done by that we can find by using work energy theorem. The center of mass is going to fall by a distance of L by 2 minus L by 2 cos 60. This distance you can see is L by 2 cos 60. This is L by 2 cos 60, right? L by 2 cos 60, and this is L. Initially it was at a height of L by 2 from the ground. So we can say that mg L by 2 minus L by 2 cos 60. This is the overall loss in the potential energy will become the kinetic energy of the rod, because we can say that friction will not do any work, normal will not do any work, because there is no sliding, there is no displacement of the bottom point. So we can say that energy will remain conserved. So which is will be equals to kinetic energy, which is nothing but half I omega square. Half into I about bottom point is ml square by 3 into omega square. So from here, what do we get? Mg into L by 2 minus L by 4. So this is L by 4, which is nothing but ml square by 2 into 3 into omega square. M will cancel out, L will cancel out, this will become 2. So we get 3g by 2L, ka under root omega. So angular velocity is 3g by 2L, which is right option. Now we have to find the radial acceleration of center of mass of the rod. Now if you see the center of mass, it will be moving in a circle of radius L by 2. Center of mass ki trajectory will be a circle of radius L by 2, and hence its acceleration will be omega square r along the point O, where r is L by 2. So radial acceleration of center of mass is nothing but omega square L by 2, correct? So this will become 3g by 2L into L by 2. So that is nothing but 3g by 4. So option C is also correct. Angular acceleration of the rod. Let's find the angular acceleration of the rod by writing the torque about point O. So about point O, the torque of friction and normal will become 0. So only mg will be giving the torque. So mg is passing like this. So we have to multiply torque of mg will be mg into this distance, which is nothing but L by 2 cos 30. Okay, this is L by 2, this distance is L by 2, and this angle is 30. So L by 2 cos 30. Cos 30 is nothing but root 3 by 2 is equals to I into alpha. Moment of inertia is again ml square by 3 into alpha. So m and m will be gone, L and L will be gone. So alpha becomes how much? 3 root 3g by 4L. So this is the value of the angular acceleration. Okay, so this doesn't match with the option A, so hence it is wrong. Normal reaction from the floor will be mg by 16. But for writing the normal, for finding the normal reaction, we can write the force equation on the center of mass. We know that net external force equals to mass into acceleration of center of mass. So if we write the force equation along the vertical direction, so there are two forces acting in the vertical direction. Friction acts along the surface. So mg acts downwards, normal acts upwards. We can say that. So mg minus normal will be equals to mass into acceleration of center of mass in the vertically downward direction. I am taking vertically downward as positive. So acceleration of center of mass we have to find. Now if you see carefully, center of mass has acceleration of omega square are in this direction, which we have already found radial acceleration. So that 3g by 4. Okay, if I show you again, so this is the rod. So this acceleration is 3g by 4. And one acceleration will be tangential, which is r alpha. R means L by 2 into alpha. Alpha is this. Okay, so if you put the value of alpha, so this is 3 root 3g by 4l. Correct? So L and L will be cancelled. So 3 root 3g by 8. 3 root 3g by 8. Okay, so we'll have to take the components of both these accelerations in the vertically downward direction. And this angle is 60. So 3g by 4, 3g by 4 into cos 60, that means half, plus this value into cos 30, that means 3 root 3g by 8 into cos 30 means root 3 by 2, right? So what do we get? Mg minus normal is equals to m into, this is 3g by 8 plus root 3 will become 3, 3 3s are 9 by 16, I guess. 9 by 16. Okay, so this will become 6 plus 9. 9 plus 6 is 15 in my opinion. So mg minus uh, n will be equals to 9 plus 6. This is 6, right? This is 16. Yeah, 9 plus 6 is 15. 15 by 16. So 15 mg by 16. Okay, so normal becomes mg by 16. Okay, so I guess this is the option B, which is again right. Okay, so again, as you can see, this was a very easy question and most of the students would have done it correctly. That's all. Thank you.